Number 4, the one that already posted for you. So that is a practice quiz. Okay, that was the one that, just check, the one that I posted. I do that one. Okay, that's a practice quiz number 4. Number 4. So the topics that we're going to cover, of course, the first topic is a substitution method. Okay, so question number 1 would be related to the substitution method. You've been asked to evaluate the integrals by substitution method. So we give you 2 questions on this one. Okay, evaluate each integral by substitution method. We can have 5 or 6 type, and we give you all of them in 2 questions on this test, this quiz, and on the final. So we just remind you the formula that you need to know. Okay, so the formula that you need to know for the substitution method are going to be the following. So the first formula is this one. Okay, integral of u to the n du is going to be u to the n plus 1 over n plus 1, the power rule, plus the constant c. You can do this formula all the time, except when n is equal to -1. So n cannot be equal to -1. Now you know it. If it's going to be -1, if it's going to be u to the -1 du, this would be the same as integral of 1 over u du. And now you know that the 1 over u is just the derivative of the ln function. So this is going to be ln of the absolute value of u plus c. Okay, so most of the problem can be done by just using these two formula. Then you are going to have one with the exponential function. So the exponential function e to the u du, exponential function never change. The result will be just exponential function. So that would be e to the u plus c. So that would be for exponential function, and we can have a similar one for the trigonometric functions. Okay, so I'm going to list all of them for you. So integral of the sine u means not sine x, anything else. Sine u du, that give a negative cosine of u plus c. That's for the sine. Then for the cosine, integral of a cosine u du is going to be, you want to find a function whose derivative is sine, okay? When derivative is cosine, that function is sine u plus c. So that would be for the sine and the cosine. Tangent and the secant are special. I proved it for you, but you can use it anytime you like. Integral of a tangent of u du. This is going to be ln of the absolute value of a secant of u plus c. So that would be for the tangent. And for the secant, integral of a secant of u du is going to be, again, you have to memorize this one. I proved it for you. Is the ln of the absolute value of a secant of u plus tangent of u. These are the formula, we accept it if you bring it as a formula sheet. But no example as I talk about. If I see any example, I don't grade your quiz or your final. So these are the formulas that you need to be able to, basically to be able to do this quiz really on the final. Okay, so, if you just replace u by x, it's just ordinary formula that you know it. But in all of them, there is going to be a situation for the trigonometric function. There's going to be a situation that this is not sine x or cosine x. Then we use the u substitution. Okay, so this is the tool that we have. Now we are going to take the problems one by one and show you how you're going to pick a best method to do the job. Okay, so the first case 1. Case 1, you want to find this integral of x, a square root of x squared plus 9 dx. So that's a case 1. So you know by now that if you want to do anything in calculus, if there is going to be any radical, you have to switch it. Okay, so you have to switch this radical first. So we have to rewrite it. So to rewrite this one, so the solution is going to be, you're starting by rewriting it. So rewriting it as x times x squared plus 9 to the 1/2 dx is a chain rule type when you differentiate it. So it's going to be substitution type. To do the substitution method, this is the way you do it. You are going to take this one to be u, and you change it to the u to the half. So your target for this problem is u to the half du. You see? And you have the formula and you can take care of it right away. Okay, you set the target, but in all these problems, I forgot to write, in all these problems, u is du. Okay, du is u prime dx. Okay, differential of the u. So what you have to do, you have to do the complete operations. So you take your u to be, you have to change it to the u to the 1/2. So your u is x squared plus 9. That's step 1. So you find the du by differentiating. Derivative would be 2x times dx times it by dx, and then you are going to find the dx. So the dx would be the du divided by the leftover, du over 2x. So that gives you the u and the dx. Go back, substitute, show that you get u to the 1/2. So this is it. So we started over. This is the substitution part that we're going to do. Okay, so that's it. We have the x times x squared plus 9 to the half. Okay, dx. So you don't have anything to substitute for x, no worry. The inside is u, is going to be u to the 1/2 times it by the dx. The dx is the du over 2x. You simplify x and x out. Remember, you are looking for u to the 1/2. The leftover is going to be a constant, the 1/2. 1/2 is a number. You can put it out of the integral. So that gives you 1/2 integral of u to the 1/2 du. And that's exactly what you predicted. Okay, now action of integrations, and the power rule is going to be 1/2. And this is going to be u to the 1/2 plus 1, 3/2. Okay, over the 3/2 plus the constant c. The only thing you have to do is just the reciprocal of, multiply the 1/2 and flip the 3/2 into the 2/3. Okay, 2/3, and that's going to be u to the 3/2 plus the constant c. So the 2 and the 2 would cancel out. So the final answer is going to be 1/3. Okay, it's going to be 1/3 u to the 3/2 plus the constant c, but you have to substitute for u. You're not done, okay? Because your final answer would be in terms of the x. So this is going to be 1/3. What is u? X squared plus 9. X squared plus 9 to the 3/2 plus the constant c, and then you're done. Okay, it's a very standard procedure. If you do it, one by one correctly, you have nothing to worry about. That's a type 1. Any question? So, the type 1 is you may have a radical expression, or you may not. So you take the inside the parentheses to be u, and you replace it by u to the 1/2, okay? So that's one of those 4 types. And that's part A. Again, this is part of your final review, so keep the solution, because we are not going to repeat this one again when we get to the reviewing the final review. Okay, so this is type 1. What is going to be the second one? The second one is, of course, a rational function. So for the rational function, there are going to be 2 cases. This is the first case. You have the x plus 3 on the top. Okay, and we have x squared plus 6x, 6x plus 1 dx down the bottom. So this is going to be the case. Now, rational function. When you want to do the rational function at this level, there are two possibilities. If this in the denominator there is a parenthesis and this raised to something, you move it up. You move it up, you end up with the integral of u to the n. But when there is no power, no parentheses, what you have to do is you have to take this one to be, okay, you take this one to be u. And this can be done by changing the integral into the integral of 1 over u du. You see, this is going to be your target. And you know that integral of 1 over u du will be ln u, and then you're done. Okay, so don't move it up when there is no parentheses, no power here. Directly consider the denominator to be equal to the u. So this is going to be u equal to x squared plus 6x plus 1. This is going to be u. Then, of course, we have to find the dx, to find the du. So the du is derivative. That is, the derivative would be 2x plus 6 times the dx. That's a dx. Okay, find the dx. So the dx is equal to du over 2x plus 6. Okay, so that would be your 2x. When you substitute, then you want to simplify, you may do something else, but keep it as is for the time being. Go back, substitute to get your target. So this is the original one. If you don't like to write it down, you can call it I, and then you just continue. Okay, this is going to be 1 dx. Now we do the substitution. We don't have anything for the x plus 3, no worry. The denominator, this is the one we call it u. Then the dx, this is going to be the dx. The dx is du over 2x plus 6. You want to simplify this for this, but sometimes you may have to do something. You see, if you factor out the 2 here, if you factor out the 2, so that gives you 2 times x plus 3. So x plus 3 and x plus 3 would be cancelled out. On the top, you get a 1. Down the bottom, we get the 2 here. So it's going to be like an integral of 1 over u. Then we get the du over 2. Okay, remember the target is 1 over u. But 1/2 is a constant. So you put it out. So that gives you 1/2 integral of 1 over u du. This is exactly what we're targeting. Okay. So as I told you, this is the type that you're not going to move it up, and you would like to do it by the ln function. And now you know that 1 over u is the derivative of the ln function. So this would be equal to 1/2 natural log ln, but remember you must use absolute value of u plus c. But substitute for u, x squared plus 6x plus 1. So that would be 1/2 ln of the absolute value of x squared plus 6x plus 1 plus the constant c. So that gives you the final answer. Okay, so for the rational function, you will see that we are going to have a second case in a minute, but this is the way we do it. There is no parentheses here. You call this one u, you must end up with 1 over u. So as usual, this is a standard for all of them. So you get the u, we get the dx, you go back, and then extra job was just factoring the 2 out here so that we'll be able to cancel out x plus 3 and x plus 3. So that gives you the final answer. Okay. So this is the first case. Any question? They may give you some trigonometric form, no problem. Like part C. Part C, you have the integral of, you have a secant of x on the top, tangent of x. And on the bottom, you have 5 plus secant of x. Secant of x dx. Again, it's a rational function. There is no parentheses, nothing down the denominator. So you have to take the denominator to be equal to the, you see, you take this one to be equal to the u. You take this one to be equal to the u. So the target is going to be, you should end up with 1 over u du again. You see, you set up this target for yourself so that you know that if you don't get it, probably you miss something. Okay, so operate, this is going to be u equal to the 5 plus secant of x. That is your u. Again, you differentiate it, du. Derivative of 5 is 0. Derivative of a secant is secant 10. So that would be secant of x, tangent of x. Okay, tangent of x times dx. And you have to find the dx. So your dx is going to be equal to, so the top is going to be your du, and the bottom is going to be secant of x, tangent of x. Okay, go back, substitute. You see secant 10 will cancel out. You get your 1 over u quickly. Okay, there you are. Originally, we have a secant of x times the tangent of x, and this is 5 plus secant x dx. So it's going to be equal to, you don't have anything for the top, no worry, you keep it. It's going to be secant of x, tangent of x. The bottom one is the one they call it u. Then you multiply by dx, but your dx is what? Dx is du over secant 10. Secant of x, tangent of x. So these two will cancel out. So the leftover at the top is going to be 1. So you arrive at 1 over u that you predicted. And you know that 1 over u is as ln of the absolute value of u plus the constant c. But what is u? U is 5 plus secant. Okay, it's going to be 5 plus secant. So the final answer is going to be, so this is going to be ln of the absolute value of 5 plus secant of x plus the constant c, and you're done. Okay, so it's a straightforward integral. It's a very, very nice one. Of course, in future, we use the shortcut. As soon as we see it, we say, oh, this is the u prime is already on the top. And u prime u is the derivative of the natural log. We write it down right away. But in calculus 1, we'd like you to, to operate with this differential. That's why you have to show us your work, if you like. Question? Again, we have one more. I do all of them for you so that you know that it's not going to be big. The natural log is very, very important one. Okay, so this is going to be the next one. The next one, you have 1 over ln x minus 1 again, dx. You see it's a rational function. You get something down the denominator. There is no parentheses. So again, you are going to call this one u. And if you do the substitution, you must arrive at 1 over u du. And 1 over u du, you have the formula for it. It's the ln of the absolute value of u, and then you'll be nicely done. Okay, so just operate again. So that's going to be your u. U is going to be 4x minus 1. Okay, that's u. Again, go for the differential of the u. So d of u is equal to derivative 4x minus 1, derivative would be 4, times the dx. So find the dx. Dx is equal to the du divided by 4. So that would be the case. Go back, substitute. If you go back, substitute, you get 1 over u here. Okay, so what's going to be the case? This is it, integral of 1 over 4x minus 1 dx equal to, okay, it's going to be equal to the integral of, you get a 1 on the top, u on the bottom. Okay, then your dx, what's your dx? Your dx is simply du over 4. Nothing to simplify it, but your extra term is a quarter. So pull out a quarter, So that gives you a quarter. Okay, integral of 1 over u du. And this is the target that we did have. And we know that it's a natural log. So this is going to be a quarter ln of the absolute value of u plus the constant c. But you have to substitute for the u. U is 4x minus 1. So the final answer is a quarter ln of the absolute value of 4x minus 1 plus the constant c. So that would be the final answer. Okay, any question? So these are the type 1 of the rational function. The type 1 means the bottom one, there is no power for the bottom one. But what would happen if you get a power? You see, they may give you the same one, but they put the parentheses around here, they raise it to the second power, to the third power. So that would be the idea of the next one. I just switch these, or I'll just do it in as is. This is part E, part D. The next one, get the part E, then we get to that one again. Part E is easy, but we want to have a complete solution, so we do it. Part E is like the type 1 that we already did it. And so it's integral of, okay, it's integral of a 2x times, integral of a 2x times x squared plus 1. Okay, x squared plus 1 to the fourth dx. Okay, this is straightforward because there's a parenthesis raised to something, and you know that you are going to take the inside to be u. So if you do your job all right, you must end up with the integral of u to the fourth du. And then that would be done easily. Okay, it's always, there is going to be, okay, expressions, a polynomial, something raised to something else. So you take the inside to be u. Okay, so start working on your u. So it's going to be u equal to the x squared plus 1 again. This is going to be your target, your u. Get the du. So differentiate. If the x squared plus 1 would be 2x, that would be 2x. That's going to be 2x dx. Then find the dx. So the dx is going to be equal to, okay, is equal to the du over 2x. So that's the u and the dx. Go back, substitute, and show that you get u to the fourth here. Okay, so this is it, the original one. So we have a 2x times x squared plus 1 to the fourth dx. Now this would be equal to, we don't have anything to substitute for the 2x, no problem. Inside is u, so that's going to be u to the fourth. Then the dx is the du over 2x. Now the 2x and the 2x would cancel out. The leftover, there's no leftover here. So simply you arrive at u to the fourth du as you predicted. Okay, and you know that the integral would be power rule, u to the fifth over 5 plus the constant c. But remember to substitute for u. What is u? X squared plus 1. So that gives you x squared plus 1 to the fifth, okay, over 5 plus the constant c. And that's it, you're done. Okay, so that was type 1 again, this they repeat it. Okay, any question? Now the next one is that rational function of the next type that we need, that's part E. So we go with the part F. And in part F, you are going to take this integral. Integral of 4x cubed. Okay, it's going to be 4x cubed divided by x to the fourth plus 1. X to the fourth plus 1, everything is square. Dx. Again, you see this is a rational function. It's different from the first group that we did. In the first group, there was no power here. In this case, there is a power here. So what do? You move it up, and that would be of this category. Okay, so when there is no power here, don't move it, so that you will see that this is going to be 1 over u, and you take care of it by natural log. But if there is any power, you move it up and you apply this method to it. Okay, so that's a difference between these. So what we have to do, we have to do the moving up first, rewrite it. So when we rewrite it, we get the integral of, okay, 4x cubed times x to the 4th plus 1 to the negative 2 dx. You see, that's going to be the one. So this is the one that you have to find. But you take the inside to be u. So your target should be u to the negative 2 du. So you take again the inside to be x to the 4th plus 1. And if you do your substitution correctly, you must end up with u to the negative 2, and u to the negative 2, easily integrable. Okay. So there you are. Start working again. U equal to the x to the 4 plus 1. That would be step 1. Step 2, differential of the u, du is 4x cubed dx, the derivative. Then find the dx. Dx is equal to a du over 4x cubed. Okay, so that's it. We have the u and we have the dx. Go back, substitute to see if you can get your target. So this is it. Originally, you have 4x cubed times x to the 4 plus 1, everything to the negative 2 dx equal to. Now, we don't have anything to substitute for x cubed, no worry. It would be canceled out. But this is u, so it's going to be u to the negative 2 and the dx. But the dx is du over 4x cubed. See, that's about. Now 4x cubed and 4x cubed would cancel out. So there is no leftover, and you arrive at your target right away. So you get the integral of u to the negative 2 du, as you predicted. Okay, any question? Now we can easily integrate. So this is going to be u to the negative 1 over negative 1 plus a constant c, because u to the negative 2, you add 1, you get it. But remember, no negative power, so we bring the u down. So that gives me negative 1 over u. Negative 1 over u plus c. But you have to substitute for the u. What is the u? X to the 4 plus 1. So this is going to be negative 1 over x to the 4 plus 1 plus the constant c as your final answer. Okay, so just make sure you differentiate these two types that we have. The type that there is a power here, and the type that we did quite a lot over here. You see all of this that we did. If a rational function, you see the denominator here, and there is no parenthesis for denominator, no power, as we did. So these are the ones that would end up in the natural log. But the other group, when there is going to be a power here, you just move it up, and at the end, you are not going to have the natural log, and you can do it by easily applying the power rule. Okay, so that will cover the two groups or two types of the rational function. Okay, any question? Now, the one with the exponential one is a kind of a unique problem, part G. You get quite a lot of this when you get to the calculus 2 if you take that course. But in this course, it's just one case. And you want to find the integral of x e to the x squared dx. You see, we gave you the formula for this one. So the only formula that you have is this. Integral of e to the u du. That would be e to the u. So what you have to do is you have to take this top one to be equal to the u this time. You take the top, the power to be, okay, so you take this one to be u. So this is going to be your u. And then the target is going to be integral of e to the u du. And you know that integral just would be e to the u, and then you're done. So it's very, very easy case. And it's very unique. We can't do anything else about it. Okay, so you start with taking the u to be x squared. That's going to be the first step. Okay. Again, differential of the u, du, would be derivative of x squared, 2x dx. Then we have to find the dx. So the dx is going to be du over 2x. So that is going to be your dx, and the u go back, substitute, show that you get e to the u here. Okay. So going back to the original one, so integral of x e to the x squared dx is going to be equal to, we don't have anything to substitute for x, no worry, e to the x squared, which is the u, e to the u, but times it by the dx, and the dx is du over 2x. Now we can simplify it. You see x and x would cancel out. So you arrive at e to the u du over 2. So the leftover is going to be 1/2. So you take it out and you get your target. Okay, so you arrive at 1/2 of the integral of e to the u du. And you know that the integral of e to the u is just e to the u. It's never changed. So it's going to be 1/2 of e to the u plus the constant c. Okay, but you have to substitute for u is x squared. So it's going to be 1/2 e to the x squared plus c, and then you're done. So it's very easy case, exponential one. And there are quite a lot, later on, but not in this course. So you must change it into the e to the u du all the time. So whatever it is on the top, you are going to call it u. And if you do the operation correctly, you must arrive at e to the u du. If you get anything else, probably you missed something. Okay, any question? So this type is easy. And that's a kind of case 4 that we have for the exponential one, because there is no other choices for this one. So what else? The leftover are going to be those kind of VIP cases that we did have. Okay, and the next case is just a rational function. So this is the way I label it. Fg, let's call this one case H. Okay, that is an easy case. And the function to integrate is this one, is a rational function, x squared over 16 minus x cubed dx. Okay, again, it's a rational function. There is no parentheses down denominator. So this is the type that you are going to call this one to be u, and you must arrive at 1 over. Remember, you are not going to move it up because there is no parentheses here. So if you take the bottom to be u, so you must arrive at 1 over u du. That would be your target. Okay, quickly we can do it. And that's it. We get the u equal to the 16 minus x cubed. That's your u. Then differential of u. Remember, these operations should be done and you get points for it. When you change it to the 1 over u, you get 50% of the grade. And the other 50% is when you find this integral. Okay, so write all the details. In case you missed the last part, so you're not going to miss quite a lot. So differential of the derivative of 16, 0, that derivative would be negative 3x squared dx. Okay, you have to find the dx. So your dx is going to be equal to, that would be your du divided by negative 3x squared. So that gives you a dx. Okay, go back, substitute. If you do everything all right, you must get 1 over u du. So go to the original one. This is x squared 16 minus x cubed dx. It's equal to, you don't have anything for the x squared, no worry. This is u. Then you substitute for dx. dx is du over negative 3x squared. You see the x squared and x squared would be cancel out. So that give you 1, that give you a negative 3. So the leftover is going to be 1 over negative 3, which is a negative 1/3. So we put it out. It's going to be negative 1/3 integral of 1 over u du. You see, that's the one. Negative 1/3 integral of 1 over u du. And you know the integral of 1 over u du is just natural log. So it's going to be negative 1/3 the natural log of absolute value of u plus c. And we have to substitute for u. U is 16 minus x cubed. So it's going to be negative 1/3. Okay, negative 1/3 ln of the absolute value of 16 minus x cubed plus the constant c. And that would be the final answer. Okay, so that's just a rational function. Again, you know, want to practice. You know, when it's given to you, you quickly recognize the method and you'll be able to do it. Okay, so that was again one of the previous one that we did, but we didn't have anything new. Now, the rest are going to be a kind of the VIPs, those one that we are going to use in calculus 2. I talk about it. And this is it. We have two cases with ln x. I talked about the other day. So this is, call it I. The I part is this integral, 1 over x ln x to the 5th dx. You see that's 1? You see whatever we did so far, and we take the inside parenthesis to be u. And the u was polynomial. You see all the time was 16 minus x cubed. There is just a polynomial of x. But this problem is different. What is different about this one? Inside parenthesis is not a polynomial. It's ln x. No problem. Call this one ln x. Okay, so we have to kind of rewrite it to remove this ln x, and then we operate it. So it's a substitution method, but a little bit different from what you have. Okay, so the solution is going to be, first step, we are going to take the u to be this inside ln x. Okay, that's going to be your u, the target. So you must know that this is u. If you do anything all right in this part, you get 1 over u to the 5th du. Then you know that 1 over u to the 5th, you move up the u and you get the result. Okay, so first thing to do, you have to take care of this ln x. Okay, inside parentheses. So that's the idea for this problem. So this is going to be over u. Can we differentiate? We know that the derivative of ln x is 1 over x. That's a 1 over x dx. You want to find the dx, cross multiply. Or multiply both sides by x. It's the same thing. So x times du would be dx. X times du would be dx. Or dx is x times du. This is how we're going to get the dx for these problems. Okay, the inside parenthesis, you call it u. Then you differentiate it, derivative of ln x is 1 over x. 1 over x dx. You multiply both sides by x, that give you dx. Go back, substitute, you must get this. So what is going to be the substitution part? So originally you have 1 over x ln x to the 5th dx. So it's going to be equal to, substitute. You don't have anything for the x, no worry. It would be canceled out. Inside we call it u, so let's give u to the fifth, times the dx. What's the dx? dx is x du. You see the x and x would cancel out. So you arrive at what? Integral of 1 over u to the fifth du. You see, we remove that ln, if you like, the natural log. Now you know that you have to move this one up to be able to integrate it. So it's going to be u to the negative 5 du. Okay, and just use the power rule. So that gives u to the negative 5 plus 1 would be negative 4 over the negative 4 plus the constant c. And no negative power, no negative number down the denominator. This sign would be a sign of the fraction minus 1 over, you bring this one down, 4 u to the 4th plus the constant c. Okay, now you substitute, of course, for u. What's u? U is ln x. So this is going to be minus or negative 1 over 4 ln x, everything to the 4th, plus the constant c. So that would be the final answer. Okay, as I told you, it's very popular integral if you want to continue taking calculus courses, and you're going to see it quite a lot. So it's sure that we give you one of them on this quiz and one on the final, because this is a very important integral. Okay, any question? So the idea is just removing that ln x first. So the inside parentheses, as usual, is going to be over u. So inside parentheses, we call it u. And then automatically, if you follow the procedure that you have, that ln would be removed. And you get 1 over u to the 5th to be able to do it. Okay, this is one case. There's going to be another case that this ln is going to be on the top. That would be much easier to operate. But this is the one that they like in calculus 2 for that 3 different places. So in this book, that gives me the last one, but I'm going to bring it up here and do it because I wanted to have them together. Okay, so this is going to be I. So if we call this one I, J, K, this is going to be, I'm going to call this one L, so that you have all of them together. This is the last one. This would be when the ln is on the top. ln x, then I come back and do the rest. You see this one? The difference? The difference is going to be the other one, ln is down the now is on the top. So again, you take the inside, okay, you take the inside to be u. If you take this one to be equal to the u, so the target this time is going to be u cubed du, which is very easy to integrate. Okay, so you look for that inside parentheses. Inside parentheses is ln x in both cases. So the first operations, the first part going to be exactly the same. You just repeat this one again. Okay, so you take the u to be ln x. That is u equal to the ln x. Then you find the du. The derivative of ln x is 1 over x, 1 over x dx. Cross multiply. So your dx is going to be x du. Same thing, go back, substitute. Everything would be canceled out, you get this one. So we have ln x cubed over x dx. Substitute. ln x is u, so that gives you u cubed over x and the dx. And the dx is x du. Now, as you can see, the x and x would cancel out. So you arrive at what? You arrive at u cubed du, as we predicted. You know that the power rule that give you to the fourth over 4 plus the constant c, but you have to substitute for u. U is ln x. So the final answer would be ln x. Okay, ln x to the fourth power. Okay, ln x to the fourth power, and then divided by 4 plus the constant c. So that gives you the final part. Okay, so this is two important cases, which is different. Okay, the format of the integral is different because, you know, inside parentheses is not a polynomial, it's just ln x. Any question? So that's going to be one. The last one is those trigonometric one. Okay, these formulas that I gave you. Just to look at the formula that you have. 1, 2, 3, 4. 4 possibilities. Give me one of them. So the exciting one, of course, going to be tangent at the secant that you got to be careful. The one that you have over here, okay, is, let's see, I think you have a tangent here. So, oh, you have a tangent and a sine. You have two here. So we're going to take care of it. Okay, so these are going to be, this is Hij, if you like. So I'm going to call this one J. And that is the first trigonometric one. And the idea is integral of x tangent. It's very unique because we don't have more tools in calculus 1. So basically, this is the case. You see, you can do the tangent of u, tangent of x. This is x squared. So for this type of problems, the inside, okay, inside the trigonometric function is the one that you pick to be u. So you take this one to be u. If you take this one to be u, so your target is going to be, you must end up with tangent of u, tan u du. And you know the integral of a tangent u du, according to that formula, is the ln of the absolute value of a secant of u, and you're done. Okay, so the only thing that you have to do is just substitution to change it to this form, okay? So take u to be x squared. That's u. Differentiate du. So the du would be 2x dx. Find the dx, which is a du over 2x. You see, that's your tools. Go back, substitute, you must get this one. So what's the original one? Integral of x, tan of x squared dx. Substitute. You don't have anything to substitute for x, so that would be just x. Tangent of, this is x squared, you call it u. Now times the dx, What is the dx? The dx is the du over 2x. That's it. Now this x and x would cancel out. The leftover 1/2. You pull it out, you get the target. Okay, so this is going to be 1/2 of the integral of a tangent of u, du. Okay, that's it. Integral of a tangent u du would be ln of the absolute value of a secant u plus c. So it's equal to 1/2 ln of the absolute value of a secant of u plus the constant c. But we have to substitute for u is x squared. So that gives me 1/2 ln of a secant, absolute value of a secant of x squared plus the constant c as your final answer. Okay, so your only job is changing the function from x to u. Okay, change it from the integration of function respect to the x to the integration of function respect to the u, and your formula is ready. So that's your extra job, okay? Any question? You have one more of these. It can be the tangent and the secant are different, but the sine, cosine are much, much easier. So that's your the next one that you have. So that is GHIJK. We can call this one K. And the K, according to your list, is the same thing, but with the sign. So integral of x to the fourth, sine of x to the fifth, just to show you all of them are the same. So that's one. Again, we can't do the x to the fifth. So what we do, we are going to call this one to be u. So this is going to be your u. So if you do everything all right, you must get sine of u du. And that would be very easy because integral of a sine is a negative cosine, and then you're done. Okay, so the procedure is going to be very similar. So we go for it, u equal to the x to the fifth. That is going to be u. Differential of the u, du. Derivative of x to the fifth is going to be 5x to the fourth dx. You find the dx. Dx is equal to the du over 5x to the fourth. That's it. So that will be your u, and that's going to be your d of x. So go back, substitute, and show that you get the integral of sine u. Okay, so this is the original one, x to the fourth, sine of x to the fifth, dx. So it's going to be equal to the, we don't have anything for x to the fourth, no worry. It would be canceled out. Okay, it's going to be sine of, but this is u, sine u, times it by the dx. So what's going to be the dx? And this is your dx. Dx is du over 5x to the fourth. Now x to the fourth and x to the fourth would cancel out. The leftover is a fifth. So you put it out. 1/5 integral of sine u du. But you have to formula here. See the formula. Integral of sine u is negative cosine u. So that gives you negative cosine u plus the constant c. Plus the constant c, then your u is x to the fifth. So this is going to be negative cosine. U is x to the fifth plus the constant c. So that gives you, oh, I'm sorry, I missed the fifth here. So it's going to be 1/5. 1/5 and the negative 1/5. So it's going to be negative 1/5 cosine of the x to the fifth plus c as the final answer. Okay, and that's it. This is all the substitution that you see over here. So 2 questions directly. Okay, there's going to be one indirectly. The 2 questions, and we give you 2 parts, 3 parts. It's a quiz, we may give you 3 parts. So we practice all these type of functions that you saw over here. So 1 from each. And the case 1, it may be a radical function. Okay, the case 2 is a rational function, but the rational function with the power inside or otherwise. Then trigonometric function on those, BIP like the LN types that you're going to have, okay? So if you study these, you shouldn't have any difficulty for this group of problems. Okay, so that was question number 1. Any question? So that's integration part. Then differentiation part. So we give you a couple of questions to differentiate. You are going to differentiate the natural log function for us, and then exponential function. Okay, so we give you 2 questions on this. This would be question number 2. Again, it's a very easy question, and we repeat it again on the final. Okay, so let's have this one too. Then we give you a break. So the question number 2 on the review, differentiating. So we want to find the derivative of each function. Find the derivative. Okay, the derivative of each function. The function are going to be either, exponential or natural log type. So the formula that we need are going to be the following. I just remind you the formula that we need. So you must know that the derivative of ln x is simply 1 over x. That's your first formula. Okay, that's the first one that you need. The second one is, if this is not going to be x, it's going to be a function of x. Of course, you call it ln u. If of ln u would be u prime u. Okay, so if it's going to be x, ln x is simply 1 over x. Okay, so if it's going to be anything else, you are going to call it u and you apply the chain rule tag. And that's the only formula that you have for the ln. And you have 2 similar one for the exponential function. So if your derivative of e to the x never changed, it's going to be e to the x. But if it is going to be e to the u, the chain rule type, you know that e to the u is going to be derivative of e to the u. Again, it's going to be e to the u, but you have to multiply by u prime. So it's a e to the u times u prime. And then you have to reverse it or switch it. This is going to be u prime e to the u. That's it. So easy differentiation with the following formula. Of course, you may have to use, quotient rule or the product rule from the past. But this is the one that you have. Okay, so there you are. The problem that we have is the first one. Y equal to ln of the absolute value of 5x to the 4th. Okay, plus 6x plus 1. Remember, during the lecture, we talk about it. It doesn't matter whether you have the absolute value or you don't have. You can use the same formula because the derivative would be the same. I just put it just to remind you. So you can drop the absolute value, ignore it, and do the differentiation. Okay. So there is not going to be absolute value around it on the quiz, but we already proved it for you that the derivative of the absolute value of u is just u prime u again. So you can think about it as ln of 5x to the 4th plus 6x plus 1 inside the parentheses. It's not ln x, so you call it u. So you remind yourself that you have to use this formula. So you remind yourself that you have to use the formula of ln u. The derivative of ln u is going to be u prime u. So just for your information. So y prime is u prime u. U prime, derivative of the inside. 5 times 4, 20, 20x cubed. Derivative of a 6x is just 6. Divided by u, which is 5x to the 4 plus 6x plus 1. You see, and you're done. Remember, you won't be able to do anything about this one. You are not required to simplify it, nothing. So just do the u prime u, and then you're done. Leave it. You can't do anything about it. Okay, that is going to be the type 1. So derivative is very straightforward and very limited cases. So that's part 1 of this question number 2. The other part, the function to differentiate, is going to be this one. Part B, the function is ln x over x. It's a quotient function. You have to apply the quotient rule to differentiate it. Okay, remember the quotient rule? Top, bottom. is going to be derivative of the top, t prime, times the bottom, b minus derivative of the bottom, b prime, times top, divided by the bottom squared. Okay, so prepare to apply the quotient rule to your formula. So y prime is equal to derivative of the top, derivative of ln x, 1 over x. So 1 over x times the bottom, times it by x, minus you have the bottom times top. Derivative of x is 1 times top is just ln x, 1 ln x. Divided by the bottom square, x squared. But do know that anytime you use quotient rule, you have to simplify it. This x and x would cancel out. So the leftover is 1 minus ln x over x squared. That would be the derivative of the function, and you're done. Okay, since you're using the quotient rule, you make sure you simplify it. Using the quotient rule, you have to simplify it first. Okay, so that's ln with the quotient. Question. Now we have one more ln. I do the ln's first, then I give you the exponential one. This is very important case, part D. Famous function. Y is equal to x cubed times e to the negative 3x. Oh, I'm sorry. I want to do D first. It's a 5. I do this one later because I want to have you or the ln function together. So it's a 5, y equal to the 5x cubed. 5x cubed ln x. It's a very important case of the ln function. You see, for this problem, you use the quotient. But for this problem, you have to use the product. So you take this one to be, the product rule, the first function, second function. So we have to use the product rule. This is product rule. Derivative of the first, f prime, times the second, plus derivative of the second times first. So that would be. So the previous one, you apply the quotient rule. For this one, you have to apply the product rule. Okay, let's do it. Y prime equal to derivative of the first. It's a 5x cubed. 3 times 5, 15. 15x squared. That's the derivative of the first. Times the second, ln x. Done. Plus derivative of the second times the first one. The first one, derivative of the second, derivative of ln x is 1 over x. Times the first one, 5x cubed. You see, but you have to simplify this one. Some people just say they stop. No, you have to continue. The simplification would be, you see, the 1x would be simplified by 5x squared, make it to the 5x cubed, make it to the 5x squared. So the final answer is y prime equal to, okay, y prime equal to the 15x squared ln x, and the leftover here is just 5x squared. You see, that's a very, very important and popular case that we have. Okay, so this is the derivative of the natural log function. You will see a couple of them. One question is 2 parts for the these natural log function, and they give you another one, and that would be when we use the exponential. Okay, I'll give you a break now. So to come back and we do the exponential one, and then we go on with we have to have a couple of optimization problem, relative max, relative mean, and of course, and the L'Hopital rule or Hopital rule that I talked about it the other day. Okay, it's a 9:10, 15 minutes, we come back, 9:25. Then we continue. Okay, see you then. Okay, so we are dealing with the differentiation. We have a couple of more over here. So we talk about the cases that involving the natural log function. There are just a couple of them too, in fact, involving the exponential function. Mostly, this is one of them is with the product, and one of them is straightforward. It's used, especially number part C. Okay, so we continue. So for the exponential function, it's straightforward because derivative is always the same. The only thing is that if it's going to be e to the u, you have to multiply by u prime. Otherwise, it's straightforward. So it's a number 2. We continue differentiating these functions. Okay, so you want to find the derivative of the following function. It's part C. You want to differentiate that the function is y equal to, okay, y equal to the x cubed e to the negative 3x. Okay, so this is a product of two functions, like the case with the ln function. So you have to use the product rule. This is going to be the first function, and this is going to be the second function. Okay, that's the first, and this is going to be second. So you have to apply the product rule. And just to remind you, derivative of the first one times the second one plus derivative of the second one times the first one. Okay, so this is it. Y prime equal to derivative of x cubed would be 3x squared. That's derivative of the first times second, e to the negative 3x plus derivative of the second exponential function never changes. It's an exponential function, but you have to multiply by u prime, derivative of the top. Derivative of the top is a negative 3. U prime, remember u prime e to the u. The formula that we apply is this one. You see, u prime e to the u. When it's e to the x, it's just e to the x. So that's a derivative of the second one, times it by the first one, x cubed. You have to simplify these two. They are monomials. You multiply them together and you put it up in front. So y prime is equal to the 3x squared e to the negative 3x. Okay, that would be minus 3x cubed e to the negative 3x. And you're done. You can't do anything about it. Don't try to do something about it, because this would be the end of the problem. Okay, it's a very popular case, and we have one application problem later related to this derivative. So that's a part C, and the part, okay, that's the part C, and that the part E, the last part of the differentiation of these functions is y equal to, okay, y equal to the e to the x squared minus 5x. It's one of the problems in your book. This is easy because you are going to call this one u. So you just differentiated e to the u. And we talk about it. Derivative of e to the u is just e to the u is e to the u, but you have to multiply by u prime. So the derivative of the function is going to be equal to exponential function would be unchanged, you see, but u prime. U prime derivative of the top. Derivative of the top would be 2x minus 5. 2x minus 5. It's done. We can't do anything about it. Some people, they like to move the e to the x on the other side. It's up to you. But if you keep this parentheses, would be fine. But if you want, you can write down as a, this would be fine really. 2x minus 5 e to the x squared minus 5x. So don't distribute it because you are not going to get anywhere, you know, to distribute this one. Okay, so that would be a question on the differentiation, derivative of the exponential function and the ln function. Now, what's going to be next? Next is going to be, we give you two problems, okay, optimization problem, finding the maximum and the minimum of the function. One of them is going to be exponential one, and the other one is going to be a log function. We did a couple of them on during the lecture, so I just have a couple of famous one over here. I'm going to try it. Okay, so this is going to be optimization problem for the exponential function. This is a very famous, popular problem in applications. They ask you to find the absolute maximum. The absolute maximum. Okay, absolute maximum value. The absolute maximum value of this function. Value on the domain of the 0 and positive infinity of the function. Okay, of the function. And this is your function, f of x equal to the 3000 x e to the negative 0.04x. You see, it's a kind of revenue problem, and we use it in different places in business, and you can use it also, in the case of the sometimes mathematical optimization is related to the mean problem in statistic. So as usual, as any other problem, if you want to find the max and the mean, you have to find the critical values first. You know that. You find the critical values, you drop it back into the function, then of course you test it. You have two choices. You may test it with the first derivative test, or you may test it with the second derivative test. So this is your job, like the first part of the course. So solution, you start with the domain of this function. Domain is given to you. You have to stay here. So the domain for this one is 0 and positive infinity. Otherwise, the natural domain is all real numbers. But you have to be, in this interval only. Now differentiate. To differentiate, this is like this function that I told you. You see, you have to use the product rule to differentiate it because you have the function. You see, this is going to be the first part, and this is going to be the second part. So you have to apply the product rule. So apply the product rule to get it. You have to have the first times second, second first. F prime of x equal to lift of the first one. You see the lift of the 3000x would be 3000 times the second function e to the negative 0.04x. That's the lift of the first times second. Less lift of a second times first. The second one is exponential function. Exponential function never changed. E to the negative 0.04x, but remember u prime. So u prime is the derivative of the top. Okay, the derivative of the top is going to be, okay. So it's going to be derivative of the top. Derivative of the top is what? Is a negative 0.04. Okay, so that's going to be one. Derivative of the first times second plus derivative of the second times first. Derivative of the first one just 3000 times second plus the derivative of the second times first. Derivative of the second one, exponential function would be exponential function, but you have to multiply by u prime. U prime derivative of the top. This is of the second times it by the first one. First one, 3000x. Just make sure you don't miss this part. Some people, they miss it when they do this problem on the test. Now we have to simplify it. So that's going to be f prime of x equal to, okay, it's going to be equal to the 3000 e to the negative 0.04x. Over here, you see you multiply these two together, and it's a monomial. You up it in, you put it up in front. So what's going to be this one? And this is going to be 4 times 3 would be 12. We get the 12,000, but we have 2 decimals over here. So we have to drop 2 of these zeros. So it's going to be negative 120. Okay, 120x e to the negative 0.04x. Okay, I'll just multiply this together. 3 times 4 would be 12,000. But we have 2 decimals. I just drop the 2 zeros. So that would be the derivative. Since you want to let it equal to 0, there is always possible to pull out this exponential function. So you better put it out. You have some other common factors, but do this one all the time. That will help you for the next part. So that give you 3000 minus 120x. Okay, this is going to be your derivative. Now you want to check a max on the minimum, so you have to let it equal to the 0 to find the critical value. So this is the way you're going to do it, f prime of x equal to the 0. So this means e to the negative 0.0 for x times 3000 minus 120x equal to the 0. Now a product is 0 if each factor is 0. So it implies that you must have either e to the negative 0.0 for x equal to the 0, which is impossible because e is a fixed number. Remember, e is 2.7. So this expression is never 0. So this nothing cannot happen. So the second part equal to the 0. So the second part equal to 0 would be 3000 minus 120 x equal to the 0. Now you solve for x. Okay, so that's the algebraic part of this problem. So it's going to be negative 3000. So your x is going to be equal to 3000. You just drop the negatives over 120. Okay, is going to be over 120, which is going to be like 300 over 12, which is going to be divisible because so this is going to be equal to 4 times 12 would be, okay, that's it, 2 times 12 would be 24, 60, 25. So x equal to 25 is going to be your critical point. So the critical point of this problem is going to be 2025. Okay, any question? So this procedure is very standard for this type of functions, and the algebraic part to remember is that you're able to pull out this exponential part. That will help you. That will help you because when you want to solve this equation, you have nothing to worry about because this quantity is like a number. It's like dropping it. So then you'll be able to find, your critical value. Now what you have to do, you have to drop this one back into the function. This is the candidate for the absolute maximum. But how do you know that this is absolute maximum? You have to test it for us. 2 different tests, first derivative or the second. Let's drop it back to the function first. Get this number, then we are going to test it, okay? So I'm going to drop 25 in that function. So x is equal to 25. You are not done. You have to find the f of 25. F of 25, replace the x by 25. That gives it 3000 times 25. E to the negative 0.04x times 25. Okay, so what's going to be the result? It's going to be equal to 3 times 75 would be 25 would be 75. Okay, so that gives you 75,000. E to the top 4 times 25 would be 100. 4 times 25 would be 100. We have 2 decimals, so that gives you just e to the negative 1, which is the same as 75,000 over e. You can keep it as is, or you can use your calculator to find the actual value. So f of 25. If you talk about dollars, okay, it's going to be an application problem. You have to use your calculator and give us the result. But otherwise, we accept it. Okay, so this is the candidate. But you have to show that this is absolute maximum. Okay, how do you know that this is a maximum? So you have to test it. Testing. So you bring your function to see what type of tests are going to use. You see the function with the part that we factoried. This is going to be your f prime. Okay, it's going to be your f prime. That was a 3000 minus 120x. You see, now you decide what you want to do. A second derivative test is not, is not a good choice. It can be done because for the second derivative, you have to differentiate this one again. Takes times. But for this one, the first test is first derivative test. You just check the sign of the f prime around the 25. Is it up, down? That gives you the maximum. Down, up, remember the minimum. First derivative test. So for this problem, the suggestion is first derivative test. First derivative test is check the sign of the f prime. And you see this part here, exponential part is always a positive number. So you don't have to worry about this one. You check the sign of this. You can check a couple of numbers around the 25 to see what's going on. So we use the first derivative test and we need a table. X, domain is 0 and positive infinity. The only number they want to check is 25, critical value. So this is going to be your f prime, okay? And this is going to be your f of x. F prime is 0 at the critical point, and f of 25 is 75,000 over E. Okay, now you have to tell us what is the sign of the f prime here or here? Two portion. So as we talk about, you don't have to check it here. You have to check with the 3,000 minus 120x. You pick a number between 0 and 25. Easy number, any number. If you, for example, use 1, you see if you put the 1 here, if you put x equal to 1, then that expression 3,000 minus 120x would be 120 times 1, which is 3,000 minus 120. It's positive, whatever result is. Since this is positive, so the f prime positive, the function increasing. You see, this is the way you check it. Between 25 and positive infinity, pick a number. Any number will do it for you. So for example, 100. If you put x equal to the 100, and if you test it, so 3,000, 120 times 100. Again, it's going to be 3,000. Okay, it's going to be 3,000 minus 12,000. It's a negative. That gives negative 9,000, which is a negative. So this would be negative. F prime negative, the function is going down. Up, down, maximum. You see? This would be relative maximum. But since you don't have anything else in your table, you have only one critical number. So this means f of 25. See? This means f of 25, which is equal to the 75,000 over E is the absolute. Okay, absolute maximum. Maximum of the function. Okay, we usually write the maximum of f of x. The maximum value is 75,000 over E. So this is the way you are going to deal with this type of problems. You need a table to be check that, okay? And my suggestion is the first derivative test, unless you don't like it. But it takes time if you want to do the second, because look at your derivative in this group of the kind of revenue function. You always get this type of function. But I've seen on the test, some people, they apply the second derivative. They find the second derivative, they use the product rule, and then they drop 25 in it to check the concavity. So they show that f double prime of 25, for example, is negative. Then they say negative means done, concave done, that gives you the absolute maximum. But why not? It's correct. But the first derivative, of course, is much, much easier. Okay, so study this one, and then you have a couple of them again, in the second part of the problem, then you'll be able to do it. Okay, that's optimization problem for the exponential function. We need one for log function. So that was a number 3. Number 4, it's a 2-part. The first part, I've already done it during the lecture. So check that one from your lecture notes. So this is problem number 4. In number 4, we want to find the absolute minimum this time. Okay, find the absolute minimum. Okay, absolute minimum of these functions. Okay, it's 2 cases, 2 famous one you have over here. Find the absolute minimum value of the function on this interval. Okay, for the given function, for each function. There are 2. I did the first one during the lecture notes, so just check it for yourself. So the first part is f of x equal to x squared minus 8x, 8 ln x, that's the first one. Okay, and the second one, part B, must be part B, f of x is equal to x squared ln x. We want to know how you are able to handle the log function. So if you go to the section that we did for the natural log, just I wanted to show you which day we did it and how this is it. This is the solution of the first part. Okay, so you check your lecture notes and then you will see it. And check it on the optimization problem or the lecture notes on 5.1, Monday 24. Okay, so you already got the lecture note for this one. So for this one, see your lecture note. So the solutions are going to be the first one, the review that we did. Okay, so for the first one, check or see lecture note or recording on 5.1. Okay, or the recording that you have. You know, it's not difficult, but I've already done it. So I do the part B for you. Okay, the part B, this is it, f of x equal to x squared ln x. Again, first thing to do, you have to find the critical value. The domain, of course, is positive numbers. You know that the natural log is defined for the positive number only. So that gives you 0 and positive infinity. Again, differentiate it. You have to apply the product rule. You have to have the first times second, second first. Okay, so f prime. Lift of the first one, lift of x squared is 2x times the second one, ln x, plus the lift of a second times first. Second lift of ln x is 1 over x times first times x squared. But we can simplify the second one, that gives you x. So the function is f prime of x is equal to 2x ln x. Okay, 2x ln x plus x. This is going to be your f prime. Like the one that we did, you have to let it equal to 0 to solve it, to get the critical value first, and then you need calculator to check if this is going to be a maximum or a minimum. Okay, so f prime equal to 0. So that gives you 2x ln x plus x equal to 0. You have to solve this equation. You are going to usually isolate the ln x first, but we can factor out the x. So that gives you 2 ln x plus 1 So again, as we did it for the other one, x equal to the 0, never, because the domain is 0 and positive infinity, and you cannot use 0 for the ln function. So this means the second one must be 0. 2 ln x plus 1 equal to the 0. Okay. Now you can find the ln x easily. So that gives you 2 ln x equal to the -1. Then ln x is equal to the -1/2. Okay, so ln x is equal to the -1/2. And then we solve for x. You know that ln is the log at base e. So x would be e to the -1/2. Okay, e to the -1/2. You can use your calculator if you don't like it. If you want to stay with this algebra, you have to rewrite it as 1 over e to the 1/2. And it's going to be 1 over radical e. So two options. The calculator may be the better one because you have to substitute in the original one, then you have to do more work to do. But if you want to keep it, it's just 1 over, 1 over radical e. Okay, but the part A, the numbers are nice, but not this one. So this is the critical value. So the critical value is 1 over radical e. So what you have to do, like the previous one, you have to go back, drop it into the function, then test it. The function is x squared ln x. Okay, any question? So it's not going to be a complicated one because you cannot do it. You cannot solve that ln function, ln equation. So that's why it's going to be straightforward. So I repeat it again. So my x is 1 over radical e. So the function is x squared ln x. And then you substitute, so it's going to be f of 1 over radical e. So it's going to be 1 over radical e squared. Then it's going to be ln of 1 over radical e. Okay, this would be equal to the 1 over e ln of 1 over radical e. You can use your calculator, or if you want to stay with this one, you can do a little bit more algebra to take care of it, but it's not a big deal. You can use your calculator to find this number. So this is, let's do it so that you can see. It's 1 over e, so that's going to be 1 divided by e, should be somewhere here. Okay, this is going to be 1 over e. Then this would be so far 0.36. Then I multiply by the ln. Okay, multiply by the ln. This is going to be the ln. And the number that I have is going to be 1 divided by square root. Okay, the square root of e. That is going to be e. Okay, a square root of e. I missed it. Is ln of 1 over radical e. So this is radical, and that's e. Okay, so we get a negative number because the ln is ln of less than 1. I get a negative 0.18 almost. So you can check it for yourself. Negative, 18. So that would be eventually the minimum that we are going to be interested in. Okay, negative 0.18. But you have to test it again. You see, that's going to be the candidate for the absolute minimum. But you have to do the testing. So testing. So you're testing your derivative, f prime of x. Again, f prime of x for this function was 2x. You see it was 2x ln x. This is what you got over here, plus x. That's the one. So you have two choices. You can find the second derivative and test this number, which is possible. ln is easy. Or the other one is you can use your calculator and check the sign of this f prime around the 1 over e to get these numbers. Intentionally, I used the second derivative because I wanted to see both of them. It can be done by the first derivative as well. So I use the second derivative test so that you know how you handle that. Okay, I have to find the f double prime. So derivative of the first time second derivative of 2x would be 2 ln x. Last derivative of the second times first, 1 over x times the 2x, and the derivative of 1, x is just 1. So f double prime of x is going to be 2 ln x. You see 2 ln x. This would be cancelled out, plus 2 plus 1. Okay, so this is going to be f double prime of x is going to be 2 ln x plus 3. You see? So you drop your numbers in it. So f double prime of 1 over radical e is a 2 ln of 1 over radical e plus 3. You see, if you check this one, this would be a positive number. You can check it with your calculator again, because we almost did this. Okay, we get the ln, it's going to be ln of 1, and then of 1 divided by radical, okay, radical e. This is it. So this is going to be, it's going to be a negative number, negative 0.5. If you multiply by 2, okay, it's going to be multiplied by 2. So that gives a negative 1 plus 3 plus 3. It would be almost a positive 2. So it's going to be almost equal to the 2, and 2 is a positive number. Okay, 2 is positive. F double prime positive means the function is going to be concave up. You're curving up. That gives you a minimum. You have to test it. You can't do it without any test. Okay, there you are. So this means f of 1 over radical e equal to the negative 0.18 is the absolute minimum. Okay, absolute minimum of the function, or you can write minimum of the f of x is going to be almost 0.18. Okay, negative 0.18. So that gives you the idea of, how you're dealing with this optimization. You need it, in future, in the application problems that you may face, you may get the natural log or the exponential function. So check your calculator, make sure you are able to, to take care of this type of problem for us. So we get 1 from each on that, okay, on the quiz, and of course on the final. We give 1 exponential function related, and there are not many functions. They are very similar to the one I just did here for you. Okay, so this is going to be optimization problem. That is number 4. Number 5 and 6. Number 5 is going to be the same thing, just a couple of functions they ask you to find where the function is going to be increasing, decreasing. You have to use the first derivative test. We did both of them during the lecture notes. So again, for number 5, check your lecture notes. Okay, number 5, you see the function is, you have 2 functions. You want to find and this is, I just write it down. Find the interval where the functions are going to be are increasing, okay, or decreasing. And determine the, okay, determine relative extrema, relative extrema. That's simply first derivative test. First derivative test, and we did both functions during the lecture. So the functions are part one. It's like the one that we did. The part one is exponential function. The part two is the log function. So the first part, the function is 4x e to the negative 2x. And the second part, the function is ln x over x. Again, if you check the one that we did on 5.1 and 5.4, you will see the solution of both of them. Okay, so I want to make sure I get time to, we go to the problem of the indeterminate form, because you have the average value. So let's go to any question? So let's go to the average value. There are two problems. I did one of them on the lecture notes. So I explained the average value on number 6. We give you one problem, but it's mostly application types. So what we would like to do is find the average value. Find the average value. Average value of the function. The function is this one, f of x equal to 3x sine of x squared. And you want to do it on this interval, on the interval of 0 and radical pi. We are interested in application types problem. If you check the lecture notes, that application type is, remember that was a temperature problem. It's given to you again here as a number 7, but we did it during the lecture notes. I just want to remind you the average value formula. You see, this is it. Average value of a function is 1 over b minus a integral from a to b f of x d of x. That's it. That's the average value. Make sure you have the formula and bring it to the test if you don't mind. Okay, now the function is given to you. It's your function. The smaller number is going to be the a. The larger number is the b. So a is 0. B is radical pi. As soon as you write it down, it's going to be a famous integral that we did. So what's the average value? Average of f is 1 over b minus a radical pi minus 0. Integral 0 to radical pi 3x sine of x squared dx. That's it. Radical pi minus 0 would be just a radical pi. So this is going to be, you can pull out the 3. So it's going to be 3 over radical pi, integral from 0 to radical pi, x sine of x squared dx. It's a kind of problem that we did, okay, and we are going to repeat it again for you. For this, you see, use substitution, and this is the one. And the one that we just did for you, look at this one. This is one. But the difference is this is indefinite integral. There is no a and a b here. For this problem, there is an a and b. So that's why we would like to repeat it so that you know it. So let's find this integral first. Then we come back and we multiply by. So we would like to find this integral, 0 to radical pi x sine of x squared dx. Now you have to use u substitution because it's the sine of x squared. So you take the u to be, you see, you take your u to be x squared. So the target is going to be sine u du, as we did it before. So as soon as you write the definition of the average value, the rest is simply the one that you did before. So do the substitution method. U is x squared, that's a u. Okay, differential of the u is 2x dx. You find the dx, which is equal to the du over 2x. Okay, there you are. You have two options. You can forget about these, just do the problem first and then come back. Some people find this one easier. So if you do the substitution, x is just x. This would be the sine of the u. Then the dx, what's the dx? Is the du over 2x. Okay, x and x would cancel out. The left is going to be 1/2. You pull out the 1/2, integrating simply sine u du. And you know that the integral of the sine u is just a negative cosine, 1/2 of a cosine of u. Don't add the c because we come back here and take care of it. So u was x squared, so we get the negative 1/2 of the cosine of the x squared. Okay, so go back. Now, integral from 0 to radical pi x sine of x squared dx is equal to the negative 1/2 cosine of the x squared, but when x going from 0 to radical pi. The other method that I'll show you, you just change the u here, but I've seen some people prefer this one, so we don't mind. Either one would be fine. But you have to substitute to get it. So it's going to be negative 1/2 cosine of radical pi squared. Okay, minus 1/2 cosine of the 0. Radical pi squared would be pi, and the cosine of the pi is 1. Okay, so this would be negative 1/2 cosine of pi. And over here, cosine of the 0 is 1, so that gives you plus 1/2. But the cosine of pi is negative 1. So that gives you negative 1/2 times negative 1 plus 1/2. So 1/2 plus 1/2 equal to 1. But you go back, remember there was a number here that 3 over radical pi, so the average value of the function is going to be 3 over radical pi. This is a problem in your book. That's why I picked this one to explain it. Okay, but study the temperature problem that we did. This is number 7, and it is on your lecture notes. I just did it for you when I talk about the average value. Okay, so we give you one average value, and number 7 is in your lecture note. See your lecture note. Okay, this is where we did the. Okay, this is where we did the average value. It must be around 4.3. Lecture notes on 4.3. You will see this problem right away because I want to make sure I have time to do a couple of indeterminate form for you. Okay, so indeterminate form is going to be easy question. We did it yesterday. There are 3 possibilities. We give it 2 out of these 3, or as one question. on this quiz and on the final. And these are the ones that you have to know. So this is the last problem for this quiz and for the, okay, it would be again on your quiz and the final. Find each limit. So find each limit. Of course, you can do it only using L'Hopital rule, okay, using, okay, that's it. L'Hopital rule. Okay, it's a one question, two parts. The first part is going to be kind of exponential type. Very popular. It's like the one that we did. And the reason that we repeat the similar one because of the application for future in calculus 2. That's the first one. You have to substitute x equal to the 0 to check to see if you get a 0, 0. That's the idea of these problems, okay? And there is a misprint over here that I haven't checked it. This must be a negative one. Otherwise, you can't do it. It can be done, but it's not going to be fun. Okay, so e to the 3x minus 3x minus 1. So why? Because if you substitute, see, solution. I just repeat it to make sure that you know that I change it. E to the 3x minus 3x minus 1 over x squared, x goes to 0. Substitute. E to the 0, that would be 0 plus 1. Sorry, minus 1. And this is 0. But e to the 0 is 1. 1 minus 1, that give you 0 over 0. Okay, in determinant form. If you don't go with the positive one, you don't get the 0, you get the number, so the limit does not exist, and then you're done. That's why we change it. Remember, when you get the 0, 0, we call it indeterminate form. So we are going to use the L'Hopital rule to do it. So the L'Hopital rule or L'Hopital rule means this limit would be the same as the limit when you differentiate the top and you divide it by the derivative of the bottom. So L'Hopital rule, limit of, you start with the given one. So, you know, you can substitute here. You don't have to rewrite it, but you have to start with the given one to tell us that you are going to use the L'Hopital rule. L'Hopital rule, differentiate, x goes to 0. The top, the top exponential function never change. E to the negative 3x would be e to the negative 3x. But remember, you have to multiply by u prime. U prime derivative of the top, which is 3. So that gives you 3 e to the 3x. That's the derivative of the top. Minus derivative of a 3x would be negative 3. And the derivative of 1, 0. Derivative of x squared, 2x. Okay, make sure you don't miss that 3 here. Now replace x by 0 again. So that gives it 3e to the 0 minus 3 over 0. E to the 0 is 3, is 1. So 3 minus 3 is 0, 0. So we get indeterminate form again. So continue. Use the L'Hopital rule again. So it's going to be equal to again. We take it from here. L'Hopital rule. The limit of. Continue. Differentiate the top. 3 is a number. E to the negative 3x would be e to the negative 3x, but times u prime. U prime, you get another 3 here. So it's going to be 3 times 3 e to the 3x. And this is just simply 0. Divide by 2. X goes to 0. Okay, 3 times 3 would be 9. So this would be 9 e to the 0 over 2. e to the 0 is 1, so that gives you 9 times 1 over 2. The result's going to be 9/2. So the limit is 9/2, and then you're done. Okay, it's not a difficult problem, but you have to pay attention. On the test, the people, they miss this. They write the derivative of e to the 3x, e to the 3x. Then you cannot continue because they are not going to get the 0, 0. So they stop here. They usually give me this answer that the limit does not exist, which is not correct. So don't miss the u prime 3 here. So again, when you differentiate again, exponential function would be the same, but you get another 3. 3 times 3, 9. Okay, just make sure don't miss this one. Otherwise, it's very straightforward problem. Okay, so this is the first part, type 1, that you have to know. There are 3 parts. I just do all those 3. You don't need to know anything else. So the type 2 is going to be part C. This is 0, 0, infinity over infinity. So we're going to handle that. Limit of ln of x over cube root of x. I did this one during the lecture, but I do it again. You see this one? Again, when x goes to infinity, ln of infinity is infinity. And the cube root of infinity would be infinity. So it's infinity, infinity. You can use the Hopital rule. You have to differentiate the top and the bottom. The bottom is a radical function. You better change it. So this is the way you do it. You say it's a limit of ln x, okay, over cube root of x. X goes to infinity. I rewrite it first. Limit ln, okay, x to the 1/3. X goes to infinity. Now, L'Hopital rule, differentiate, limit, remember, limit, limit, limit. X goes to infinity. Limit of the derivative of ln x is 1 over x. Derivative of x to the 1/3 would be 1/3. X to the 1/3 minus 1, x to the negative 2/3. Now carefully, you have to simplify this one. The way we do it, we change this one into the positive power. Limit of 1 over x. This would be 1 over 3 x to the 2/3. X goes to infinity. It's a division of 2 fractions. So it's going to be the first fraction, 1 over x, times the reciprocal of the bottom, 3 x to the 2/3 over 1. Now we simplify it. That's a 2/3 out of x to the first power, 2/3 out of 1. The leftover would be 1/3. So this would be the limit of just, that's it, the limit of the 3, okay. Yes, the 1/3 would be 3 on the top, 3 on the top. The leftover would be x to the 1/3 on the bottom. X goes to negative infinity. Okay, the power of the bottom is higher, so x/3 would be. So this would be simply like the limit of 3 over cube root of x. X goes to infinity. This would be 3 over infinity, which is equal to the 0. Remember, pizza problem. This limit is always 0. It doesn't matter whatever they give you here. ln x over x squared to the 4th to the 5th is always 0. So again, it's not a difficult limit. I just, most of the time it's not a radical, but I just give the radical, just get to know it. So most of the time is x squared to the 5th to the 6th. So be careful and show that the answer is 0, but you have to prove it. Okay, so this is case 2. The only other case is 0 times infinity. Let's give you that one too, but we give one question, 2 parts. One part is going to be either the first one or the second one. And the second part, of course, is going to be this last case. And we repeat it on the we used to give you 2 problems of this on the quiz and the final, but we don't want to have too many questions for the final. So the last case is part D. Again, I did it during the lecture notes, so you should have it, but I repeat it again. You want to find the limit of this function, limit of x to the fourth ln x, when x goes to 0 positive. Okay, we talked about it the other day. The answer is 0, and you have to prove it. Okay, it doesn't matter. The one that I did the other day was x squared. This is x to the fourth, can be x to the fifth, x to the sixth, radical x, cube root of x. All of them are the same. Now, the way we do it, remember, this is going to be 0 times, when x goes to 0, limit of the ln x would be negative infinity. We talked about it the other day. So we can do it only if you write this one as a fraction. Means you change it to the 0, 0 or infinity, infinity. We talk about how we're going to do it. So the solution is going to be, is the limit of x goes to 0 positive. You have x to the fourth ln x. You want to change it to the fraction. This is the way we do it. We get a fraction bar. We keep the ln x on the top. Okay, we flip x to the fourth, or if you bring it down. If you bring it down, the power would be negative. That's it. Because if it's a negative, you move it up, you get the next one. So we haven't done anything wrong. But since we change it to this form, you have the infinity over infinity, and we can use the orbital rule. Okay, some people make a mistake on the test. They write ln x over x to the fourth. Doesn't make sense, they are not equal. So what we did, we keep the ln x, we flip the other. Now the rest is easy, it's just like the previous one. Just differentiate, L'Hopital rule. So it's going to be limit of x goes to 0 positive, differentiate, ln x, 1 over x, x to the negative 4, negative 4, x to the what? Negative 5. When you differentiate, you know, you lower the power. Then you have to simplify it. You can do the same thing as we did for the others. Limit of 1 over x, negative 4 over x to the fifth, but x goes to 0. Is going to be the product of the top times the reciprocal of the bottom, 1 over x. Reciprocal of the bottom is going to be x to the fifth over negative 4. Simplify. You see, in this case, when you simplify, there's going to be leftover of the x on the top. So the top would be the limit of x to the fifth, x to the fourth. The bottom just a negative 4. But this goes to 0. If you substitute to 0, you get 0 over negative 4, which is 0. Okay, again, it's not a difficult problem. But I told you, you are going to rewrite it. They are not equal to each other. Rewriting means you fix the ln x as is, you flip the x to the fourth, or you bring it up. When you bring it down, it's going to be x to the negative 4. You have to switch the sign. Okay, then you switch the sign here, then you get infinity over infinity. The rest are exactly like the previous one that we did. And that's it. That's all I have time to do. And I did almost all of them. So study this one carefully. As I told you, 6 questions of this quiz would be repeated right on Thursday. Very similar to this. So it's a double bonus to study this one carefully. You get a good one on this quiz, and quickly we get a good one on the test. So the other 6 questions are going to be, you know, the one like mean value theorem. Okay, we talk about it. It's going to be over review. Of course, 2 more questions are going to be coming from the inverse of trigonometric function that we cover on Monday, and the other 4 would be just, you know, a couple of things from the past. But the basic one is this one. So study carefully. Okay, that's it. I will collect your papers this afternoon, and I start grading it, grading test 3. When I'm done, I just post the result for you. Then I drop your lowest test. So by By the end of this week, you will see the test one. Your two highest grade is going to be called test 1 and test 3. And I drop the test 1 and test 2. And I drop the kind of a test 3, the test 3, not the test 3, your lowest points. Okay, so don't be surprised if you see a change of grade when I'm done with the grading of the test 3. And then when done with the quiz, I will drop your lowest quiz. So by Tuesday, you have a clear idea of what you need to do on the final, okay, to pass this course or to get an A in this course. Okay, I have to go for my next class, so have a good one, and let me know if you need anything. Study this one carefully, really. It's double bonus, really. Okay, take care. Bye-bye.